In this video, we're going to be talking about chance experiments and events. So suppose two six-sided dice are rolled, and they both land on sixes. Or a coin is flipped, and it lands on heads. Or record the color of the next 20 cars to pass an intersection. These would be examples of chance experiments. A chance experiment is any activity or situation in which there is uncertainty about which of the two or more plausible outcomes will result. Now, suppose a six-sided dice is rolled. The possible outcomes are that the dice could land with one dot up, or two, or three, or five, or even six dots up. So here, this is what we call our sample space. A sample space is the set of all possible outcomes of a chance experiment. The S stands for sample space. We use set notation to list the outcomes of the sample space. The sum of the probabilities of the outcomes in the sample space equals 1. Now, suppose the two coins are flipped. The sample space would be heads, 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 tails, tails, heads, and tails, tails, where H is heads and T is tails. We can also use a tree diagram to represent this sample space. So we flip a coin, we either get heads or tails. Then we flip again. If we had heads the first time, we can either get tails or heads the second time. If we have tails the first time, then we can either get heads or tails the second time. We follow the branches out to show that possible outcome. Now, suppose a six-sided dice is rolled. The outcome that the die will land on an even number is going to be 2, 4, or 6. This is an example of an event. An event is any collection of outcomes or a subset from the sample space of a chance experiment. Now, we typically use a capital letter to denote an event. What would the event be that the die is not landing on an even number? Well, that would be 1, 3, and 5. This is the complementary event. So a complement consists of all outcomes that are not in the event. The superscript C stands for complement, but you can also use prime or a bar to denote the complement of E as well. The sum of the probabilities of the complementary events equals 1. Now, these complementary events can also be shown in a Venn diagram. So if we take our event 2, 4, and 6 and the complementary event 1, 3, and 5, we can draw a rectangle, and we're going to let the rectangle represent our sample space. And we're going to let the circle represent our event E. So we're going to have the shaded area represent the event that's not E. So everything that's not E is yellow. Now, let's go back to our dice. So a six-sided dice is rolled. We get 2, 4, 6. So the event that the die would land on a prime number would be 2, 3, or 5. So then the question could be asked, what would be the event of E or P happening? And that would be the numbers 2, 3, 4, 5, and 6. This is an example of a union of two events. The union of A or B consists of all of the outcomes that are in at least one of the two events. So that is in A, or in B, or in both. So we would say A or B, and we have A union with B. And this symbol right here, this like smiley face, it means union. So consider a marriage or a union of two people. When two people marry, what do they do with their possessions? Well, they put all their stuff together and then they live happily ever after. Because the bride takes all of her stuff and the groom takes all of his stuff, and then they put it together. So this is similar to the union of A and B. All of A and all of B are put together. So let's revisit the rolling dice, right? So we can get an even number or a prime number. So we get 2, 3, 4, 5, or 6. So another way that we can represent this is with a Venn diagram. So we have our sample space, then we have our circle that represents our even numbers, and then we have our sample space or a circle that represents our prime number. Why is the number 1 outside of those circles? That's right, because it's neither even nor is it prime, so it doesn't belong inside of those circles. Now, E or P would be any number in either of the circles. So let's take the same situation. What would be the event of E and P happening? Well, it'd only be the number 2. This is an example of the intersection of two events. The intersection of A and B consists of all of the outcomes that are in both of the events. So we'd write A and B, or A in a little rainbow, B. So that symbol right there, that little rainbow arc, this symbol means intersection. So let's come back to our E and P. So we have the number 2. We can represent this with a Venn diagram as well. So we have our sample space, we have our even circle and our odd circle, and of course our 1 that is outside that doesn't belong. Now our E and P would be only the middle part that the circles have in common, hence the number 2. Now let's think of something different. Suppose a 6-sided dice is rolled. Consider the following 2 events. The event A, the dice is rolled and it's a 2. Or event B, that the dice is rolled and it's a 6. So on one single roll, is it possible for A and B to happen at the same time? No, because you have to roll the dice and you're either going to get a 2 or you're going to get a 6. These are what we call mutually exclusive. Mutually exclusive or disjoint events are 2 events that have no outcomes in common. 2 events that never, ever happen simultaneously. So a Venn diagram for the roll of a 6-sided dice, where you would get 2 or a 6, well, not or 6, event A would be a 2 and event B would be a 6. Would look something like this. We have our sample space, that is our rectangle. We have the circle for 2, the circle for 6, and our 1, 3, 4, and 5 in our sample space. So here we can see that A and B are mutually exclusive or disjoint since they have no outcomes in common. The intersection of A and B is empty, again, because they have nothing in common. So we're going to do a little practice here with some Venn diagrams. So on the next 4 slides, we're going to find some Venn diagrams representing the students at our school. Some students are enrolled in statistics, and some in calculus, and some in computer science. So for the next 4 slides, we're going to indicate what relationships the shaded regions represent using complement, intersection, and union. So here we have statistics, calculus, computer science in our sample space. Look at the colored portions, the shaded portions. Here we have calculus or computer science, so the union of calculus and computer science. Let's take a look at the next one. So I want you to go ahead and push pause and go ahead and write down what you think it is, and then push play, and let's see if you're right. So here we would see that we have statistics or computer science and not calculus. So here we have, if we let statistics equal event A and calculus equal event B and computer science equal event C, we have statistics or computer science, so the union there, with the intersection of not calculus. So notice that we have that little B prime, meaning the complement, meaning not calculus. Let's try another one. So here we see that we have statistics, calculus, and computer science. Again, let statistics equal A, let calculus equal B, and computer science equal C. Go ahead and push pause and try this one on your own, and then let's see how you do when you're done. Push play. Here we have statistics and computer science and not calculus. Let's try another one. So we're going to go ahead and we're going to let statistics equal A, calculus equal B, and computer science equal C. So go ahead and push pause Give it a try, and when you're done, push play, and let's see if you're right. Here we have statistics and not computer science or calculus.